All right, what's the answer to number 1? 3. Because x is in my numerator, I'm going to be able to get away with just one multiplication here. If we multiply both sides by the denominator that's under the x, we only have to multiply one time. The 12 distributes to the 2 up here, so we have x equals 24 over 8, and 24 divided by 8 comes out to be 3. What is the answer to number 2? 10. This time, because x is in the denominator, you have to multiply by both of the denominators, so you're going to have to do multiplication twice. It does not matter which denominator you decide to multiply by first. So I'm going to multiply both sides by the 5 first. So I would have 6 equals 60 over x. Then I would multiply both sides by the other denominator, multiply both sides by x. So then you would have 6x equals 60. Divide both sides by 6, and you get that x is 10. What is the answer to number 3? 2.5. Absolutely correct. Did you have a question?
So I did number 2 and 3 a different way, and I didn't get 10 or the next answer for the other one. For number 2, I did times 12 on both sides, and then for number 3, I did times 12.
Okay, so for number 3, you can multiply both sides by 12, but when we multiply, you always multiply by the denominator, whatever number is on the bottom. So that's why on number 2 you didn't get the same thing, because 12 is a numerator, it's up on top. We only multiply by what's on bottom. Yes? I'll come look at it in just a minute and see. All right, so on this one I would multiply both sides by 12 first. Come on. That's going to distribute to this 3 right here. It's going to cancel my denominator out there. So I would have x plus 2 equals 36 divided by 8. What is 36 divided by 8? It's not 5. What is 36 divided by 8? 4.5. Doesn't come out to be a whole number there. And then you subtract 2 from both sides, and that's how we get that x is 2.5. For numbers 4 and 5, there's at least 2 different ways to correctly set up those problems. I'm going to go through it one way. We can talk about other ways to set it up that would also be correct. On number 4, we need to find x, and x is right here on the left-hand triangle. What side would that correspond to on the right-hand triangle? 3. Both of these at the edges have an angle marking there. So I'm going to set up a fraction with the x and the 3. Doesn't matter which one you put on top, but if you put the x on top, you usually can get away with just one multiplication. And then we're going to make a fraction with these remaining 2 numbers. Which one should go on top? 4, because it comes from the same triangle that the x is coming from. And then we multiply both sides by 3. That's going to distribute up here to my numerator of 4. So I have x all alone on the left-hand side. X equals 12 over 6. So x is what? X is 2. The other way that you could have set this one up, so right now I have the corresponding pieces making my fractions. I could also make a fraction to solve this one for x where I stay within the same triangle and the corresponding piece has to go in the other numerator or denominator depending on where it is. So I could set up a fraction that was x over 4, but then if x is in my numerator, the corresponding piece 3 would have to be in my other numerator. So that would be another correct way that you could set up and solve that one. Last one now, number 5. One of the ways that you can go about setting this one up, and you can only do this because of these parallel lines here. We can make a fraction with these two numbers that are on the same side of the triangle. So I can set up a fraction that's 2 over 3. And then the other fraction would contain the other side of the triangle, the x and the 4. So then to solve this one for x, we would multiply both sides by 4. So then I would have 8 over 3 equals x, which is a fully simplified fraction. Nothing that goes into 8 also goes into 3. So I could leave it like that as my final answer, or I could pop it into my calculator, and you get 2.6 repeating. So either one of those would be correct. There are, just off the top of my head, I can think of 2 other possible correct ways that you could set this up. Give me just 1 second here. Instead of staying on the same side and on the same side to make my 2 fractions, yesterday in the warm-up, we saw that we could also have, as long as I'm staying in between the same 2 parallel lines, so I could set up the fraction of 2 over x. Let me write this down before I get too deep. You could do 2 over x is equal to 3 over 4. These pieces are in between the parallel line and the point. These 2 pieces are here and here in between these 2 parallel lines. So you could set up a fraction like that you could solve. You would get the same exact final correct answer. Or the other thing that you could do is you could separate it into 2 separate triangles. If you had the larger triangle and the smaller triangle, this would be 3, this would be 4. This entire side over here would be 2 plus 3, so that would be 5. And this side down here would be x plus 4. So you could set up a fraction that was 5 over 3 equals x plus 4 over 4. So that's, again, just off the top of my head, that's 2 other correct ways that you could set up and solve this problem. All right. Test is tomorrow, so we won't have a warm-up tomorrow. That means you're going to go ahead and turn in your warm-up page today. If you want to go ahead and pop that into the basket and then get out your test review. So here you divided those. Yeah, that's perfectly fine. So we multiply first, but multiplication and division are like they happen in the same step in the order of operations. So you can pick which one you want to do first. So that is a correct method. I'm sorry, Chloe. All right. The rest of class today, at least until the D lunch bell, is devoted to answering any questions you guys have off the review. So go ahead and grab your reviews. Any problems that you were having difficulties with yesterday or that you got stuck on last night, I'm more than happy to go over. If it's one that you just want to check your answer against mine or you want to hear me talk through it, I'm happy to go over anything in the packet. Number 8, and you wanted? Oh, A on number 1? We will do both of those. So I'm going to do number 8 first, and then we'll go back and we'll do number 1. Number 8. All right, so on number 8, it says that DF, FG, and GD are mid-segments. Before I even look at this picture, we talked about 2 properties that mid-segments have with the third side, the side that they don't intersect. Does anybody remember even one of those properties? What do we know about mid-segments and the side that it doesn't intersect? It is in your extra notes. So I'm looking at like these sides right here, because that would be a mid-segment and the side that it doesn't intersect. What would be true about those 2? They're parallel. So a mid-segment is parallel to the third side, or the side that it does not intersect. What was the other property? It's half. Mid-segment is half of the third side. So I want to come over here and look at the picture now. Right here, this segment, this is where X is, and they asked me to find X. Is this a mid-segment? Is FD a mid-segment? Yes. What's the side that it does not intersect? What? BC. So this would be my third side. And we know it is 12. So that mid-segment FD is half of the third side, so half of BC. Mid-segment is X minus 7, so I can substitute that in the place of FD. How big is BC? 12. Well, what's half of 12? So X minus 7 equals 6. X equals 13. We add 7 to both sides and we get that X is 13. Lots of room, not a ton of work. All right, let's go back and look at number 1 then. Because I was asked about number 1, part A. We can talk about part B if you want to also. All right, sounds good. Let's do both parts A and B here then. All right, determine whether the dilation from the figure on the left, so the left side figure will be my original, to the figure on the right. So the right-hand side one will be my new. We want to determine whether it's an enlargement or a reduction, and then we want to find the scale factor of the dilation. So original, because it's on the left, and this one is my new one because it's on the right. Same kind of orientation on part B. This little guy here is my original, and this is the new, because it tells me left is always original, right is always new. Make sure you read the directions, because it's not always that way. They might say the original one is on the right, and the dilated one is on the left. Make sure you read your directions there. Whichever one it says it's from, that's your original. 2 is your new. All right, now we need scale factor. Scale factor is equal to new over original. Well, the only thing I know about this new pentagon is 0.5 meters. So that's got to go up in my numerator. And the only measurement that I have on the original is this side right here where it says it is 7 meters. So I could write that down as my scale factor, 0.5 over 7. I'd like to make it prettier though. Normally we don't have decimals inside of fractions. If I divide this on my calculator, it's a really gross decimal. It doesn't come out to anything pretty like 0.25 would. So I want to think about how to make this a prettier looking fraction. 0.5 is the same as what? 1/2. So I'm going to rewrite that numerator as 1/2. It's still kind of gross though. Now I don't have decimals inside my fraction, but now I have a fraction inside my fraction. Let's see if we can figure out how to get rid of this fraction right here. What operation gets rid of fractions? Multiplication. And what part of a fraction do you multiply by if you want it to go away? The denominator. What's the denominator of this little yellow circled part? 2. So I'm going to multiply by 2. But the same way as when we're reducing fractions, if you divide the top by 2, you have to divide the bottom by 2. If I times the top by 2, I also have to times the bottom by 2. All right, let's simplify this. What is half of 2? 1. And what is 7 times 2?
14.
There's a pretty version of my scale factor. If you wrote 0.5 over 7 on the test, or you wrote the decimal version of 0.5 over 7 on the test, I'm still going to give you full credit for it. But I do want to show you how to take something that's very messy looking like this and turn it into a much prettier fraction. So that's a very useful skill. Is this an enlargement or a reduction? This is a reduction. My original one is bigger. The new one is smaller, so this is a reduction. What about part B? Is that an enlargement or a reduction? Enlargement. The new one is smaller. Sorry, the original one is smaller and the new one is bigger, so that's an enlargement. This scale factor is much easier to find. Scale factor is still going to be new over original. What's the only measurement we know on the new rectangle? 12 inches. Over, what do we know about the original? 4 inches. And so now I can divide those. This divides much prettier than the first one. What is 12 divided by 4? 3. So we have a scale factor of 3. Yes. Number 3, absolutely. We want to list all of the congruent angles, and we want to write a proportion that relates the corresponding sides. We could do this problem even without the pictures. All we need to do this problem is the similarity statement. Remember, that similarity statement already matches up the corresponding and therefore congruent angles, and it matches up the corresponding sides. So let's do angles first. Angle Q, first letter here, would be congruent to what other angle? W, first letter, first letter. So Q and W are congruent. You do not, but I'm marking the picture so that we can see that. Angle Q is congruent to angle W. What's another match I could make? Angle T and angle Z. Those are both last letter, last letter. All right, what else? R and S, second letter, R and S, R and X, sorry, I think I heard that wrong. R and X. Angle R congruent to angle X, and then S and Y. You guys said X, and I still keep trying to write S. I'm sorry. third letter, S and Y. All right, now my proportion of sides. I can still use the similarity statement to help me do this. Looking at the figure can sometimes help, but it can also sometimes confuse me and mess me up. So I'm going to look at this. I'm just going to move my way across this shape. Sides are always 2 letters, so I'm going to look at 2 letters at a time. So first 2 letters here are QR. What are the first 2 letters for the other rectangle name? WX. Those 2 are going to make a fraction, so QR over WX. And now I'm going to scoot that over one place. Instead of QR and WX, let's leave out the Q. And so then I would have middle 2 letters, which are what? RS and XY. So RS over XY. Those two fractions would come out to be exactly the same because these figures, sorry, I called them rectangles earlier, these four-sided figures, these quadrilaterals, are similar. All right, I'm going to keep moving those little boxes over. What would my next fraction be? ST over YZ. How many sides does each figure have? How many sides do these two similar figures have? 4. How many fractions do I have? 3. I need one more fraction. I need a fraction for each pair of sides. So we've talked about QR and WX. I think you're on it. We've talked about RS and XY. We've talked about ST and YZ. What are the sides that we've left out? QT and ZW or WZ, yes. When I look up at the names, that's the first letter and the last letter. So 2 at a time. The very last fraction, though, I might need to look at my picture and figure out which one I've left out. Or I can look at my similarity statement and I can look at the first and the last. So there's my proportion of sides. What else do we want to see? Yes. Number 7, absolutely. We are told that ST is parallel to QR. There are, at a minimum, 3 correct ways that you could set this up. They want us to find the length of PT and the length of PR. I'm going to find PT first. Since I don't know how big it is, I'm going to call that my X. Because the lines are parallel, I can use a setup that's similar to the fifth question on the warm-up or to our warm-up yesterday. I can stay on the same side of each of these, of the triangle, and I could write a proportion that was 28 over 11.2 equals X over 16. Or, still using those parallel lines, I can set up fractions that are like this. So we could have X over 28 is equal to 16 over 11.2. Either way of setting that up is fine, and I'm going to show the third way of setting it up after we're done solving this. I'm going to go ahead and solve this one. You get the same answer either way. Since X is in my numerator, I can get away with just one multiplication. So I multiply both sides by 16. 16 multiplies to the 28. What is 16 times 28? 448. Divide that by 11.2. 40. Came out nice and pretty. So that is PT. Now that I know PT is 40, how can I find PR? We add 16 to it. Yes, PR is PT plus 16. Absolutely correct. 40 plus 16 gives us 56. All right, so I showed 2 possible ways to set up those proportions. There is a third way that you could use. The third way that you could use if you want to is by drawing those 2 similar triangles, the smaller one and the larger one. The smaller triangle has one side that is 28 and an unknown side. The larger triangle, I have to make sure to do some addition here. This entire side is the x and the 16 added together. That's exactly what we did to find PR. And then to find this entire side, I would have to add 11.2 and 28 together. So that would give me 39.2. So then I would match my corresponding parts. X and x plus 16 would be corresponding. So I could make a fraction that was x over x plus 16. And then 28 and 39.2 would be corresponding. So this would be another way of setting that up. So at least 3 different ways that you can set this up. What else would you guys like to see? Number 6 sounds good. After that 5? Sure, we'll do 6 and then we'll do 5. Number 6, parallel lines again. Which means I can set it up like this or like this. I can't do this because if you look at part A, I don't actually have triangles. It kind of cuts off before it makes that triangle shape. So I can either stay on the same side of each of these, and I can set that up as 3x minus 5 over 2x plus 8 equals 5 over 4. Or you can stay between the same 2 parallel lines and set your fractions up that way. If you set it up like that, you would have 3x minus 5 over 5 equals 2x plus 8 over 4. Either one of those would be fine. Which one do you guys want me to do? The light blue or the dark blue? All right, let's do light blue then. Just, that's the first thing that I heard. You get the same answer either way, so it does not matter. If we're doing light blue, we need to multiply by our denominators. Let's multiply by the horrible looking denominator first. Let's multiply both sides by 2x plus 8. The 5 would have to distribute to both of those numbers since it's a binomial. So I would have 3x minus 5 equals 10x plus 40 over 4. Then we would have to multiply by our second denominator. So we're going to multiply both sides by 4. That has to also distribute to my binomial. So 12x minus 20 equals 10x plus 40. Need to get my x's to the same side, so I would subtract 10x from both sides. That would give me 2x minus 20 equals 40. To make the minus 20 cancel, we're going to add 20 to both sides. So I get 2x equals 60. And then we divide both sides by 2, and x is 30. Right, so there's part A. Part B. We know that ST and QR are parallel because it tells me right there. Can I do this one like part A? Can I set up fractions like this? I've got both of these pieces, but I don't have these parts. So I can't set it up like the light blue on part A. Can I set it up like the dark blue on part A, where these would be my fractions? No, because again, I still don't have these pieces. So what I can do here, I got to be careful the 3x plus 7 and the 9 are corresponding, so I can make a fraction out of that. But I cannot make a fraction out of these two. So I'm going to redraw both of these triangles so that we can kind of understand why. All right, so there's my smaller triangle. There's my larger triangle. On the smaller triangle, the bottom is 9. And the right-hand slanted side is 5. On the larger triangle, the bottom is 3x plus 7. This side, though, is the one that'll cause grief, because only this much right here is 16 plus x. I want this whole thing. What would I need to do to get that entire side? Add the 5 and the 16 together. We do 5 plus 16 plus x. 5 and 16 are like terms, so we can combine those. What is 5 plus 16? So I have 21 plus x on this side. Now I can set up my proportions. We need to match corresponding sides. 5 and 21 plus x are corresponding sides. So I'm going to make a fraction with those. We already said that the 3x plus 7 and the 9 are corresponding. So I can make a fraction out of those. Multiply by our denominators. Doesn't matter which denominator you pick first. You're going to have to multiply by both of them. All right, so that would be 21 plus x equals, don't forget this 5 has to distribute to both parts of the binomial. So I would have 3x times 5, so that's 15x. 7 times 5 is 35, and it's over 9. Then we need to multiply both sides by the second denominator. We've got to multiply by 9. It's going to distribute to the 21 and to the x. It's going to cancel out on the right. So I would have 189 plus 9x equals 15x plus 35. Get our x's to the same side, so I'm going to minus 9x from both sides. So 189 is equal to 6x plus 35. Subtract 35 from both sides. That gives me 154 equals 6x, and I ran out of room. Then I divide both sides by 6, and this does not come out very pretty. What is 154 divided by 6? 25.6 repeating is what my x value is there. You don't have to put what?
12 sixes.
No, you could put 25.6 with the repeating sign over the top. You could do 25.66. You could do 25.67. I would accept all of those, or 667. Number 5 was the next one I was asked for. So let's go do that one. John is standing near a lamppost and wants to know its height. He realizes he's formed similar triangles. We don't have to show they're similar. We're being told that they're similar. And can use proportion to solve the problem. John is 6 feet tall and his shadow is 8.5 feet. So that's the first thing I'm going to draw. Let's draw John and his shadow. He's 6 feet. And his shadow is 8.5 feet. Since the lamppost is also casting a shadow, that means there has to be some other light source here. The sun's rays are forming the third side of our triangle. John is making a right angle with his shadow. The lamppost casts a shadow that is 20 feet long. So there's my lamppost. We don't know how tall it is, so I'm going to call that X. We do know how long its shadow is. That is 20 feet. The lamppost and its shadow are forming a right angle. The sun's rays are giving us the third side of that triangle. So now we can set up a proportion. What would correspond to the X right here? 6. Height of the lamppost corresponds to John's height. So X over 6 equals, if my first fraction is about both of their heights, what should the second fraction be about?
The shadows.
Their shadows. Which one goes on top, the 8.5 or the 20? The 20. X went in my first numerator, and that's the lamppost height, so the lamppost shadow has to go in my second numerator. So 20 over 8.5. Since I have my X up in the numerator, I'm going to be able to get away with just one multiplication here. So I have X equals 120 divided by 8.5. This comes out to be a very gross number, but X is right about 14.118 feet. That's when you round up. If you look at the first three numbers on your calculator and you just write those down, you don't do any rounding, it would be 14.117, which I would also accept as a correct answer here. We have 14 more minutes until the D lunch bell. What do you guys want to see? Yes. Number 4? Absolutely. Yep. It's because we rounded. If you put an equal sign, that would be perfectly fine. I would accept that. But I use the squiggles whenever we do rounding in here. All right, number 4. We need to determine whether the triangles are similar. If they're similar, then we need to write a similarity statement. So triangle something is similar to triangle something else. And we need to give a reason for that. We have 3 reasons. Angle-angle similarity, side-side-side similarity, and side-angle-side similarity. So if they're similar, it's got to be for one of those three reasons. If they're not similar, we have to explain why they're not similar. It's not enough to just say not similar. Number 4, part A. Which of the 3 reasons should I be trying to show? Angle-angle, side-side-side, or side-angle-side for part A? Side-side-side, because I have all 6 sides. You have to match the smallest together. So 11 and 8. So that's going to make a fraction together. Doesn't matter which one you put on top, as long as you stay consistent. Then we have to match the largest sides together. So 13 and 10. And my medium-sized sides get matched together. So 12 and 9. We're going to put these all in decimal form, and they have to come out to be 100% exactly the same. No more numbers, no less numbers, no different numbers. Has to be the same. What is 11 divided by 8? 1.375. What about 13 divided by 10? Are those 100% identical?
Nope.
Then these are not similar. We have to give a reason for that. My reason would be that the corresponding sides are not proportional. All right, part B. They already have these vertical angles marked for us, but if they didn't, we are allowed to come in and mark vertical angles as congruent. Should we be trying for angle, angle, side, 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 or side, angle, side?
Side angle side.
Side, angle, side. Sounds good to me. So then I have to decide what to match the 12 with. 8. It doesn't matter whether I match it with this one or whether I match it with this one. It's going to be 12 over 8 either way, right? So I have 12 over 8. Yeah, the other one would also be 12 over 8. So those are identical. I don't even have to put them in decimal form. I see that they're exactly the same. If you put them in decimal form, they both come out to be 1.5. So the triangles are similar by side, angle, side similarity. And then we have to write our triangle similarity statement. Just a couple minutes left. This one's interesting. Because I have two sides that are 12, that means that top triangle is an isosceles triangle. That means these base angles of D and F are congruent to each other. Two congruent sides means two congruent angles. We got the same thing going on in this bottom triangle. Both of those sides are 8, so that means angle A and angle C are congruent. They're congruent to D and F because we already showed that these triangles are similar, and the corresponding angles are congruent when my triangles are similar. All right, so one of the ways I could write this similarity statement, triangle DBF is similar to CBA, or I could say that triangle DBF is similar to what? ABC. The only reason I have two ways of doing this is because these are isosceles triangles. Inside the triangle, there are two congruent angles. All right, let's look at C and D. What reason should we try for on part C? Angle, angle, side, 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 or side, angle, side? Let's try side, side, side. So smallest with smallest. So I have a fraction that's 3 over 4. Is that equal to, and then biggest with biggest, 7.5 and 10. And then we match our third sides together, the 6 and the 8. I did left-hand triangle over right-hand triangle. So all of my numerators are coming from my left-hand triangle. All of my denominators are coming from my right-hand triangle. What is 3 divided by 4? 0.75. What is 7.5 divided by 10? 0.75. So far, we're looking good. What about 6 divided by 8? 0.75. You do have to check all three of them. We've had a couple problems in this module where 2 of them match, but the third one doesn't. So because these 3 match, the triangles are similar by side, side, side similarity. And then we have to provide that similarity statement. There is only one way to write this one. Let's call the first one DBC. I like that. DBC. Now let's be really careful on the next one. I'm going to look at the first 2 letters here. DB. I'm going to go look at that side. Here's side DB. What did that correspond to on the other triangle? YW. Those were the corresponding sides that we made a fraction out of. So Y and W have to be my first 2 letters. Which one should come first, the Y or the W? Y. So this is going to be triangle YWX. X. I want to show you why it has to be that way by looking at the second two letters. Second two letters here is BC. That side corresponds to XW. So when we named this first triangle, it was D, then B, and over to C. These two sides correspond, and these two sides correspond. So it would have to be Y, W, X. So that I keep my corresponding pieces together. All right. Halfway through number 4. This is a long one. On part D, despite what my eyes might tell me, yes. Like all of, no. There won't be just one question with 6 parts to it like this. But 2 questions that are separate where each one is this kind of idea, that would absolutely be fair. Or even 3 questions would be fair on the test. KL and XW are the same size according to those congruence marks. I know the picture doesn't look like it, but that's what the congruence marks mean. Are there any other sides of these 2 triangles that are the same size? Yep, and L and YX. Do we know anything at all about the third sides? No. Do we know anything about any of the angles? What are the 3 possible reasons we can use? No, my similarity reasons. Sorry, I don't think I asked the question clearly. What are we allowed to use as reasons for why triangles are similar? Side, angle, side. Side, side, side. And angle, angle. Those are my only 3 things. We already established we don't have all 3 sides. And they didn't tell us anything about any of the angles. Do I have enough? No. These are not similar. Not enough information. Side, side does not prove similarity. All right, last 2 pieces. Let's look at part E. Part E, there is nothing here except for these 2 little marks. What'd you say? Yes, we can mark our vertical angles even though it wasn't marked for us. We're always allowed to mark that. They didn't tell me anything about the sides at all. No congruence marks, no lengths. So I'm probably not going to be able to use side, angle, side, or side, side, side. So I'm trying for angle, angle. Yes. We have parallel sides and a bow tie shape. What kind of thing can we draw when it's parallel lines and a bow tie shape? A Z. That helps me find my congruent angles that are tucked into these corners. We could have done our Z the other way. That would still have me going over my parallel lines. Does anybody remember what we call these angles? These are alternate interior angles. And because the lines are parallel, those alternate interior angles are congruent. So the triangles are similar by angle, angle similarity. Now we need to write our similarity statement. Let's call the first triangle RAS. What angle corresponds with R on the other triangle? C. What about A? A and S? B. So triangle RAS is similar to triangle CAB. Last one. This is going to be the last one that we can do because we only have 1 minute until the D lunch bell, although I am still happy to help anybody during that time and answer any questions you have. On part F, I've got 1, 2, 3, 4 congruent angles. Do I have at least 2 pairs of congruent angles? Yep. These two are congruent, and these two are congruent. So the triangles are similar by angle-angle similarity. So a lot like part B, we have these isosceles triangles. I know that they are isosceles triangles because those base angles are congruent. So that means I'm going to have two different possible correct ways that I can name this. So TRU is similar to, I keep saying congruent, but it's similar to QRS. Or what would be the other possible way? Let's keep TRU the same. SRQ. And again, the only reason there's two ways to do this is because those are isosceles triangles. Each triangle has two congruent angles in it. I want to show you guys real quick where you can find the answer key, where you can find all the videos from all of my geometry sections from today. So that way, if there's a question that I didn't go over in here, you can always get in and check the videos from other classes to see if I explained that one in another class.